welcome to session 3BC for GSE UK 2021. This session will be presented by Ash Mahey and Matthias, I'm not even going to try and say it, from Rocket Software, and obviously Ash from IBM. And this is a presentation regarding IBM's Monitoring Configuration Manager. As always, I remind you that at the end, if you can fill in your feedback and also dig deep in those pockets as we're getting to the end of the conference, and show your appreciation for the time and effort provided by the speakers. And show it by donating generously to our charities, lifeboats and guide dogs. And excuse me. At this point, I'll hand over to Ash and Matthias.
Right, hi, thank you. My name is Ash Mahey. I'm one of the product managers at IBM, and today with Matthias, we'll go over the monitoring configuration manager toolkit and the updates, recent updates that have been made available. What I would like to show on this slide is that we've had 3 sessions registered at the GSE, and we had a session last week and on Wednesday, and you can see it's 3AK, and that gave an overview of what's new. So which PTFs were delivered over the last several months, and so it gives you a good overview of our product portfolio updates. And today we're on 3BC, and this is the IBM Z Monitoring Configuration Manager, and the good tricks and trades of what a configuration manager does, and the updates that Matthias and the team have provided recently. And I was quite excited with the latest update, so you'll learn about that, and I believe there's a demo. Matthias will cover most of this session. And then another exciting development tomorrow, so please do join us on 3BH. And this is using your OMEGAMON data with your visualization and AI ML platform of choice. And you can sense probably from the title what that's referring to is data availability in other platforms. And so how do you achieve that with the OMEGAMON portfolio and the development? And we announced something yesterday, so you'll learn more about it tomorrow. So I do encourage you all to join our team tomorrow and learn more about how you can visualize OMEGAMON data in other tools. And so I'm going to pass this on to Matthias now, who will go through the presentation. I would like to suggest if you do have questions, add them to the chat. I'll monitor the chat box, and I will stop Matthias when applicable or appropriate. Otherwise, at some point in time, we will open the microphones for yourselves, and you can talk to Matthias and ask me questions if you need it. But it's interactive, so we do encourage you to ask questions through the chat window, and we can open the mics. Thank you. Over to you, Matthias.
Thank you, Ash. Yeah, this is Matthias Schaffler. I'm product owner for Configuration Manager in PalmGen, as well as for OMEGAMON DB2. And today I'll be introducing Configuration Manager to you, and I will dive a little deeper on the latest updates. There will be 2 parts to this. There will be a presentation part and a demo part. So as Ash mentioned, feel free to chime in if you have questions. We can keep it interactive. So let me start with the value proposition for IBM Z Monitoring Configuration Manager, or just Config Manager. It's twofold. It's ease of use and up and running. Ease of use in a sense of making it as easy as possible for you to get an RTE up and running with the least possible actions. And for those of you that have used PalmGen, the approach to use PalmGen to build an RTE is ISPF panel driven and involves submitting several jobs, checking job outputs. And by the end of the session, you will hopefully see the big difference between using PalmGen and Configuration Manager. On the up and running side, besides getting you up and running quickly, We also want to make it as cheap as possible for you, and also as easy as possible for you to apply maintenance to existing environments. So what is Configuration Manager on a high level? It is a new way to configure your OMEGAMON environments. It is providing an alternative to ParmGen ISPF dialogues. At the same time, it builds on some of the ParmGen infrastructure. So it's not a complete rewrite of the configuration, but it's a a different way to approach the mechanism. The major difference here is that it is a batch only driven process, and we will learn about that in detail as we move along in this presentation and the demo. One of the concepts that we are using in Config Manager is what we call sparse runtime environment parameter specifications. So essentially, we ask you to specify only those configuration values that you really want to change, and everything else is kind of hidden from the configuration. All of this is then saved in what we call a runtime environment definition dataset, or RTE-def dataset. We delivered this pretty much 1.5 years ago. It was initially supported by the IBM Z monitoring suite only, but we quickly moved towards opening this up to other suites, other configurations outside of a suite. So in the meantime, we'll see that on the next slide. We support all the standalone agents that are part of the IBM Z monitoring suite and service management suite. We recently introduced a new functionality which we call centralized configuration management, which I will go and talk a little bit in more detail later on. You will find also a few PTFs as we move along. We try to react on bug fixes we find internally or reported from customers very quickly. So you can look up the most recent maintenance here if you want to give this a spin, hopefully after this presentation. All right, so this is the list of the agents that we support. So as I mentioned, it's standalone and suite offerings at pair. So you can read that up when you download the materials. We've gotten requirements to extend this further, so there will be additional agent support going forward. One thing I want to highlight is the documentation. When you go to the OMEGAMON shared documentation under the configuration topic, there is ParmGen and Configuration Manager listed. Before you probably start working with this, you can have a quick look at the PDF that you can download from here and check it out. It's written very well, easy to understand, easy to follow steps, and it should help you to create your first runtime environment very quickly. So make sure you check this out and use that as a guideline to create your first RTE using Config Manager. A few words on the architecture, the underlying architecture. I mentioned it's a batch-driven process. Essentially, we have one single batch job that drives our configuration manager actions. What the actions do is they trigger the internal workflow engine, which is called KCI Omega, to perform certain actions. Those actions are performed by workflows. They look a little bit like JCL skeletons, but they are calling out to sub-workflows that each of them performing different tasks as part of the configuration process. At the end, these actions will build your runtime environment datasets, and the started task definitions and the parameter members will be generated. Everything that you need to proceed further with your deployments. In addition to that, we have a built-in discovery functionality. It's a discovery workflow encapsulated in a program called KCI Alpha. KCI alpha is an APF authorized KCI omega alias under the covers, but it allows you to discover information for KICS, IMS, DB2 subsystems, network stacks, and a few other things that you will not have to kind of figure out yourself during the configuration process. As I mentioned, all of this is driven by a single batch job. On this slide, we see the net of this batch job. We provide this job as part of a sample. So in the TCAN SAM library, you have a member called KFJ-JMCM, which is a skeleton of this job. Walking through this job, besides the usual exec and steplib statements, the KCI flow DD points you to the main workflow called KFJ Omega. And this workflow ingests the input from KCI vars DD. And the input is very straightforward. We have an action verb that tells us what action should this workflow perform. So there are lifecycle actions like create, discover, generate, and delete. And we have more like kind of utility type actions with migrate, package, and deploy. And we'll look into the last three in a little bit more detail on slides. And we'll have a demo on the first four actions following this slide, the slide part. The additional two parameters are obviously the RT name that you want to create and a high-level qualifier specification on where your RT-def dataset should reside. And then you would submit those jobs accordingly, and they would build your runtime environment definition dataset. So this RT-def dataset or runtime source library is structured in the following way. So this is a sample that you see on this screen. We basically divided the configuration on a per product basis and isolated those members in specific dataset members. All of these members, or most of these members, are optional, so you don't need to specify them. You can specify them, and if you do so, you would just add whatever configuration parameter you want to change from the default. You would add that to the respective member. So let's take the example of DB2. So KD5 is the prefix for the DB2 related parameters. We have different scopes for these parameter members, and they have an inclusion hierarchy, so to speak. The general scope of an RT-def dataset is the sysplex. So all your runtime environments in a specific sysplex can reside in one RT-def dataset, which allows you to be very portable and encapsulated without having to go through different places. It's all in one place essentially. So the scope of sysplex is denoted by the $parm suffix of your configuration parameter member. You can also have LPAR scoping when you have LPAR specific parameters. And LPAR takes precedence over sysplex when you have the same parameter in both members, for example, which you should obviously not necessarily have. What this LPAR tie-in allows you is to have a capability of including product-specific configurations per LPAR. That was quite tricky with ParmGen. You had to use sysyn overrides, or people have written their own edit procs or macros to accomplish that. Now you have first-class support for this, and you can tie in also multiple LPAR-specific configurations. The last member in this hierarchy is the discovery member. It's denoted with this @ sign, and this is produced by the discovery mechanism. Besides that, you have RT name parameters and global parameters that are always there because they contain the main parameters that you need for your runtime environment. So just a quick overview of the lifecycle actions. You would start with the create action. If you have a lot of practice with this, you can probably skip the create action and take your created RTDEV template and just go on from there. But typically you would start with create. We'll do that in the demo as well. You would make some initial configuration settings on high-level qualifiers, started task prefixes, and so forth. And if you're interested in discovery, you can run the discover action, and it will tell you what it finds on the specific LPAR in terms of subsystems. The core of the RTE generation or creation is the generate action. Generate does allocate all the RTE data sets. It produces the runtime configuration members in ARC and PARU and such. It does USS related operations. It links the classic security exits and so forth. So all of that is done for you by executing the generate action. After you have performed generate, you have a runtime environment created. You would follow the complete the configuration steps as per manuals, as you just like you did for ParmGen, to get your APF authorizations in place, to copy your started task definitions to your proclibs and so forth. And if you're done with a proof of concept or just playing around with it, you can use the delete action to clean up after yourself. So let's look a little bit deeper into a few more actions. And let me start with migrate. So the migrate action comes in handy if you have existing ParmGen configurations, because you can use migrate to import all the configuration settings that you made in the ParmGen configuration into your RTEDEV dataset. So what it does is you point it to the wconfig file and the RTE name that you want to import. You submit the job with the migrate action on, and it will produce an RTEDEV dataset with all the KPP $parm members for your specific products, containing all these parameters that you have specified and changed from the defaults as provided with the product that you have installed at this point in time. So it's very, very easy, should be very easy to get you to Config Manager. Right now, we support the one-to-one migration, so you can migrate one RT at a time. If you want to combine them into a single RTDEV for the Sysplex, you would have to do a bit of manual cleanup, but in general, that should be manageable. I want to mention that we also migrate also honors security exits and embed overrides. We got that question frequently, and it will be isolating those in specific data sets that are used then by the generate action. All right, so let's go to the most recent addition that we made, a month ago or so, which we called centralized configuration management. Previous to this PTF, you had to run this configuration manager jobs on the target system to build everything and to do the generate and the configuration changes. You had to be on the target system to fully exploit all the functionality. So with the centralized configuration management, now you can do two things. You can generate your RTEs on a local system, on a local LPAR, for example, and you can package the RTE in a set of transferable images and deploy those images on your target system. So that therefore reducing your CPU consumption on the target systems and just keeping everything on a local LPAR that might not be the production LPAR. So when we talk about centralized configuration management and what I call story one for the centralized create, we have given you an option to use different high-level qualifiers for your local generation as for your target libraries, because that was a request that we saw from different customers. So that is driven by a KCI bars DD parameter called KFJ local plib highlef. By specifying that, you can essentially have a mapping member that will allow you to map the local to the target high-level qualifiers in a very straightforward way. So let's look a little bit at the details of these package and deploy actions. Again, all of this is integrated in the simple batch job and with package and deploy action extensions. So you could call that with package, specify the RT name and the plib highlef, and it will work out of the box. All right, so what does package do? Package creates a series of dump files for you. Why a series of dump files? First of all, there are RTs that can get very big, and it might be more manageable to have smaller dump files. But also functionally speaking, these dump files have differences. So we distinguish between two types of packages or package files. One we call main packages for VSAM and non-VSAM, and the other part is about history files, which are VSAM and non-VSAM. So when you run the package action, we will produce those 4 dump files along with the metadata file, which is in charge of mapping your local to target high-level qualifiers if you decided to use this option. So when you run that package action, you have a few possibilities to tweak it. You can tell the package action that it should terse those dumps for you. If you want to transfer them later on using FTP, that comes in handy. You can specify the high-level qualifier for your package action if you have certain, storage implications that would allow you to better share this with your remote systems or virtual tapes and things like that. So you have this flexibility to customize this. The same actions are then used by, the same customization capabilities are then used by the deploy action, which effectively does the restore of those dump files. So if you say deploy RT name on the target system, after you transfer those dump data sets, it will honor a terse option and it will try to find the terse data set. It will honor the high-level qualifier and so forth. So it's kind of a symmetric support of those KFJ_pack parameters. So what deploy does is it reads those dump files, it restores them, but it uses the high-level qualifiers as per your RTDEF definition, because the RTDEF is really reflecting how the high-level qualifier structure should be on the target system. Okay, so if you have this situation, make sure you're not forgetting to transfer the metadata package file, because that will do the reverse mapping essentially for you. What deploy does for the main packages, it does a replace for those packages. So they are considered read-only. So it does replace those data sets. For the history-related data sets, they are not replaced because we might kind of override data that you have collected on the target system, obviously. So you do not necessarily have to transfer the history data sets because you have them already allocated. So typically when you roll this out the first time, or typically after you have enabled history, you would transfer those history data sets, but then in subsequent maintenance runs, you would just omit them. And by splitting this, we keep the package size low. One comment on maintenance. As I mentioned, when you apply maintenance on your staging system and you want to deploy it on the target, it will be enough to have the main VSAM and main non-VSAM dumps transferred accordingly along with your metadata file. All right, so this is like a little flow chart that shows you how such a sample deployment could look like. We would start with a simple create action where you build your runtime environment. On the remote target LPAR, you would run the discover action to discover your subsystems, your system symbols, your your respective subsystem information. You can run this discover action in a standalone way, so you can use the config manager job with discover without the previous create after you apply this maintenance. We actually also provided you with a little utility that will produce what I call here config manager partial, which will give you just a small subset of the SMPE data sets that you need to run the discover and as a matter of fact also the deploy action on your remote system. The background here is that if you have full runtime environments as your RTE types, you obviously do not have an SMPE copy on your target system. So for those cases, we provide you with this capability to produce those data sets and keep them on the target LPAR without using too much space. So you don't need the full SMPE environment there. If you're using sharing with SMP configurations, you have those on the target system anyway, so you don't need to do anything and you can run discover at any time. So when we discover this, and you would do that for all the LPARs in your sysplex, you would transfer this data set over to your staging system or your configuration LPAR and merge these members into the main RTE-def. It's probably just a copy job that you would have to do to copy this from RTE-def2 to RTE-def1 dataset. The next actions are fairly standard. You will continue customizing your runtime environment. You would generate your RTE datasets. We can selectively generate this for a specific system. And for that purpose, there is a KCI vars DD statement called KFJ sysname. So if you specify that to be sys1, we'll create the RTE for sys1. If it's sys2, we'll create it for sys2 and so forth by pulling in the respective members that are LPAR specific. After generate, you would call package. You could terse it or not. You can transfer those packages over to your remote system if they are not shared from a tape or a storage perspective. And then you would run the deploy action to put them, deploy them on the target system. So that's really the flow of actions that you would run. Okay, this next points are really just a textual description of this flow chart, so I'll skip over them. This is the point where I would jump to the demo. If there are any questions in the chat, Ash, maybe we can take a few.
Yeah. So the question is, if I use remote deploy on Sandbox, number one, I need the DASD for the all RTEs to build ADR-D SSU tapes, ? And the second was, I lose use of Omega Alpha discovery. And that was a question as well. So the second question, I believe you've answered. You don't lose the use of Omega Alpha, right? Discovery.
Well, you if you pre-generate those RTs, I'm not sure what's meant with losing KCI alpha functionality. You cannot really, these jobs, the discovery jobs need to run on those target systems because that's where the subsystems are, right?
Yeah.
So if you want to do discovery on those remote systems, you would have to run it remotely. If you don't need to run discovery because you know what your subsystems are, and you can create that member following the documentation or the minimum set of parameters that KCI Alpha gives you, you don't have to run it remotely. You would just key it in manually. On the ASTI storage, yes, that's true. You would have to allocate the storage on that local system. So that's unavoidable actually. I mean, this is the images that you transfer essentially.
Okay, those were the two questions. Hopefully we answered the questions. If not, please let us know, and we can open the mic as well if needed.
Mm-hmm. Yes, absolutely.
Okay.
Okay. Thank you. Okay, so let's do the demo now. This demo will create an RTE from scratch for with the default configuration for the following products: for the TEMS, the TOM, the ZOS agent, the network agent, and the KICS agent. So I have an SMP installation that has these agents installed, and we'll see what it takes to build the RTE for this environment. The first action we run is the create action. So let's submit this job. And again, this job is based on the sample job in TCAN-SAM. If you want to check this one out. Okay, so first action is create. So let's see what create does for us. Let's check the STSF output. So the first thing for every configuration manager job that you would look at in the output is the KCI print. KCI print gives you a high-level overview of what the workflow is doing. It tells you what maintenance level you're on and so forth. So this step did create an RTDEV library at this place as instructed by plib-hylef. It also creates the SecExit library, which contains the security exit modules that you would customize for enabling external security for your respective classic collectors and such. And it tells you that an initial set of parameters has been created for you. So let's look at what these data sets contain. I'm not going to spend a lot of time on SecExits, but this is really the usual suspects here, where you can specify your command level security, where you would add your enable your external security modules and so forth. The reason we decided to keep this separate is just because this is security relevant. You might have special protection for people to look at these things. So that's really one of the main reasons we wanted to keep this separate. But this data set is being honored by the following actions. So let's look at the RTDEV data set. So what create action does, it creates 3 members in this case. There might be more depending on the number of agents that you have, but those are 3 in this case. There is the RTE name member called demo, because we called the RTE demo, and this member contains the main RTE parameters plus a section on what configurations are active, or what agents you can configure with this SMP installation. So what we do is we find that this SMP installation has a TEMS, a TOM, a KICS transaction server, a KM5, and a KN3 network agents as potential candidates for configuration. So it sets them to yes. If you don't want to configure them, you just flip this flag to no. I just leave it as default for the sake of this demo. You see the reference to the security exit library here, the data set that I mentioned. if you decide, for example, to have one sec exit for all your RTEs, you can just remove the RTE name mid-level qualifier and have them all point to the same sec exits to achieve a common configuration from that perspective. So besides some high-level qualifier specifications, you have a block on security parameters that you should think about communication between the components. I want to point out that, excuse me, I want to point out that there is a few parameters that are new for Configuration Manager. One of them is RTE-COM Protocol 1, or there is 1, 2, 3, 4, 5. What this parameter does, it ensures that the communication between the agents and TEMs always uses the same protocol. So you can obviously override that at the agent level, but it makes sure that if in case you decide to change this from IP pipe to S pipe when you go to production, you just need to change this in one place, run the generate action, and it will reflect this change for all your agents. So you don't have to go to the respective agent configs to make this change and keep it in sync. So just to ease the number of configuration steps and keep consistency. And then last but not least, we have Apple ID prefixes that you might want to specify and your USS RT there, which by default now points to var RT home instead of /RT home. So I'm gonna just emulate a few configurations that you might be doing here by running a little macro here that will just set port numbers and USS paths to things that are valid. Because we do some validation, for example, on the USS RT there. If that does not exist, you would not get very far with your generate actions. So let me save this. If you have additional RT parameters that you are interested, you can add them in this member, save them, and then do the generate run, which does honor those parameters afterwards. When you run a migrate, you will see that this data set will then have all your RTE settings from as changed or modified or used in your ParmGen configuration, as long as they are not concurring with the product provided defaults. Okay, so let's leave this member here. Let's go to the next member. This is, in this case, fairly straightforward. Again, I'm customizing this a little bit before we go into some details. So this reflects the target high-level qualifier, which in this case points to my SMPE environment that I mentioned earlier. The Java directory for this sysplex in this case. TCAN jar path and the CSF module. If you're not using this encryption module, you can just comment this out or remove that line. If you have agents like DB2 or IMS, the create action will populate a few more members here pointing to the respective load libraries. So we'll try to make sure that you think about those things ahead of time, other than running into validation errors while doing the runtime environment generate. Right, so I'm gonna go and out of this one. The last one that is generated is the TEMS member, and the create action assumes that you will have a hub TEMS. Typically, when you have a remote TEMS, there are a couple more parameters that point to the hub TEMS, so you can add them here if this runtime environment has a remote TEMS, and you would save it in this member. So, and that's all the parameters that you have to think about right now. The next step here is then to run Discover to add a bit more context to configuration and to give you the full minimum configuration for things like network. So let's go and run the Discover action. Discover needs a APF authorized library and needs KCI alpha, as I mentioned earlier. So we'll change the program to KCI alpha and run Discovery. You can abbreviate this if you like I'm doing here. We'll submit the job, and we'll check out what our KCI print says. So return code was 0. We'll go to the KCI print. And you will see that we found three DB2 subsystems on this LPAR. We found a few queue managers, some KICS regions, IMS regions, and we found a TCP IP stack on this system. Plus, we discovered system symbols 39 in this case. The KCI print tells you also where these discovery settings are being written to, and they're obviously going to the RTDEF dataset. So let's look at those. As you might have noticed, the discovery is always a full discovery across all the subsystems that we support. So in this specific case, since we do not have DB2 or IMS, this is essentially for your information only. And you can decide to remove those members if you like. They can stay in there, they wouldn't do any harm. So let's see what we find for the respective agents. This is KC5 is for the KICS agents, and all of those prefixes are documented in the manual, so you will understand the product prefix and which parameters should go in the respective members. Oops, that's wrong. So what this KC5 add does, it pre-generates definitions for your task history. You certainly would want to give it a bit more than just one cylinder here for the task history, but that's something that you after the discovery you would think about. Is it a KICS region with lots of traffic, so your vSUM sizes are bigger? So that's not something that discovery really can find out for you at this point. The KICS subsystems itself are discovered by the agent when it comes up, so there is no additional settings needed here. So this is for the pure purpose of helping you to create those KICS task history definitions. From a DB2 perspective, we find, we discover all the subsystems, the versions, the load libraries for you, and whether it's a data sharing group or not. So this is really the absolute minimum that you would need for DB2. You might have to tweak the port numbers a little bit for your performance expert server if you use that functionality. Similar thing for IMS. For IMS, we also discover the main parts here, and we also honor the respective prefixes for started tasks and VTAM definitions. So that way you can save some work on keeping those in sync. KMQ, and this is this hashtag in a member means that this is not honored by the workflows. It's like a comment, so to speak. And in this comment, we tell you that we have discovered those queue managers, and you can add these settings if you want to the respective embed override if you just want to monitor specific queue managers. So it's like a helper member for you. Last but not least, and in this configuration, very important is the network definition. So we populate this parameter table with the respective network stacks that we find. In this case, we just have one. And those are the parameters that will then be used in the respective configuration members. And last but not least, the system symbols that are being discovered, and they are needed for the centralized config management. Okay, so that's all discovery produces. Just I like to keep things clean and simple, so I'm just gonna go and remove those things that are not needed, and that way you see this is really everything from a configuration perspective that you would need to configure an environment out of the box with default functionality turned on for TEMS, TOM, network, ZOS, and KICS agents. So it's really a very small set of configuration parameters, structured and sparse to that extent. So the next action, and this is really when we are getting into creating the runtime environment datasets, is the generate action. So I'm gonna go and submit this job, and then we'll look at what we have. So far we had these two data sets. Let's keep that in mind after we come back to make the difference or delta. Let's look at this job again. KCI print, the first thing you wanna probably look at. And in KCI print, we see that yes, we are creating a runtime environment for 5 agents: TEMS, TOM, KICS, networks, and KM5. So those are the 5 agents. We call them agents. And you see which parameters are used or are read by the generate job. You will notice RSB2. This is the LPAR specific members. In this case, we honor RSB2 because of the sysf, but you can use the KFJ sysname here, which is probably more appropriate in this case. So you could specify KFJ sysname as a KCI var statement here. Name RSB2. That will have the same effect as doing it through a sysf. Okay. And this is actually how you would do it when you do a generation of a runtime environment on your local system, because you obviously do not want to have that run on a remote system. Okay, so oh, it's already completed. Generate already completed. So how long did it take to create that full runtime environment? About 1 minute and 20 seconds. Okay, so, and what did it do? It created the full runtime environment data sets for you. It created all the KICS history data sets that we discovered, obviously just with one cylinder here, but you get the idea. It generates all the history data sets for PDS version 1 history, in this case for the TEMS. It creates the usual RCAN data sets, RCAN, command U, par U, mod U, and so forth. You know, the full runtime environment is created for you in this 1 minute and 20 seconds. For the there are additional data sets that are created that I want to mention here. One of them is the proclip member, sys1 proclip. This member contains all the started task definitions that are generated. So if you look, for example, at the KICS started task definition, you see that this member is created by KCI Omega. Why do I mention this? You might have noticed that this is really just the net of what that started task is without several lines of comments. We got fairly strong feedback from several customers that the started task definitions that are created are very verbose in terms of having tons of comments. So we tried to address this with Config Manager. We effectively post-process the generated started tasks with all the comment details and create this cleaned started task member for you and put it in this specific location. You can still look at the detailed one in your respective Arcan SAMU or Arcan RKD2 SAM members. So we did not take them away from you. There are also other things that I just want to point out. When we look at the output of generate, and you see this job is doing quite a bit of things. There is also validation that you find here. Let me just see. It's par fval. Oops. Right, so there is a DD statement that gives you some insights on the parameter validation. In this case, it is not showing any errors, obviously, because the workflow would stop if there would be an error. But if you kind of did a typo to one of the configuration parameters, the workflow will stop at this step, and you can look at this DD statement and see what you need to fix. You don't need to go to a member in wconfig and find out what is the typo that I made, or what value did I miss to configure. So it's all within the same job output that you can work your way through any user errors. In case you have any issues which you need to open a case for, this job also contains diagnostic information for us to recreate your RTE-def in-house. So there is this DSN PRT out, which effectively flattens the RTE-def dataset and only the RTE-def dataset with the respective information, so that we can identify any misconfigurations or reproduce the issue in-house. So all of that is built in, and all you need to do is really submit the full job output of a generate action if that is causing an issue. Again, in sense of ease of use, or making it easier for you to find issues, those are considerations that we try to implement. All right, so you have the RTE-def now. You can, for example, use this member here and copy the started task definitions to your respective proclip. Obviously, you might not have the privileges to do so. You might have to open a ticket or so, but the ticket might just say, take the contents of this data set and push them to sys1 proclip, and then you're over with, instead of pointing to different places in the generated RT. Again, in the sense of ease of use in this case. Okay, to wrap it up and to complete the life cycle, so to speak, I will just run the delete action here for a moment, which will tear down my my RTE and clean up after myself for this demo here, so that my sysprocs don't scream at me.
Matthias, just a quick question.
Yeah.
KCI Alpha, is that shipped in the standard, or is it a specific FMID to be installed?
Good question, and I know where the question comes probably. As opposed to ParmGen, which required the ZDLA FMID to use discovery, this is built in to HKCI 310. So it's a load module that you get with one of those PTFs, and we call the program from that load module. So nothing else needs to be installed for discovery.
Yeah, so no ZOS DLA needed.
No, it does similar things that ZOS DLA. We obviously don't have the we did not want to clone ZDLA, but some of these things are can be done without installing a new FMID. Right?
Yeah, agreed, and it's more streamlined as well. So good.
Right. Okay, so this is what the lead leaves you with your original SecExit and RTEDEF, of course, and with these proclip members. These 6 data sets that are left here are left because they might be used by more than just one RTE. So we did not want to kind of remove them. Especially here, the proclip will contain all the started task definitions for all your RTEs in that specific RTEDEF. But in my case, I can just safely remove all of this, and I'm back to where I left off for my generate run. I said, okay, I made a mistake with my high-level qualifier. I go in there, I change the high-level qualifier to GSE UK1. I rerun generate, and I'm done. Okay, so maybe a few words, if there are no more questions, since we have a few more minutes, one question that I frequently get is, yeah, what if I have new parameters? Which member should I use and create for in the RTEDEF? So the answer, and I partially, hopefully, have explained this in the presentation, is it depends on the scope of the parameter. If it's an LPAR specific parameter, it would go to KPP $LPAR. If it's a parameter that you would want to use for all of your RTEs, like for example, a feature in DB2 for enhanced 70 threat history, if you want to make sure all RTEs in your sysplex use this feature, you would put it in KD5 $PARM and enable it this way. So that is one of the things. And if you, let's assume you have a OMEGAMON for JVM agent, and you would want to change the default, what is it called, the node ID, you would create a KJJ $PARM member and add that specific parameter in that member and run your generate, and we'll honor that for you.
I've got a couple of minutes left. I just wanted to ask if you could just quickly explain if you've got a PTF, you apply a PTF, you just rerun the create job, right, and push the data sets out. You don't have to go through discovery again and all of that.
No, actually, that's was one other question I wanted to, one other comment I wanted to make is maintenance. So in 9 out of 10 cases, to apply maintenance, all you need to do is run the generate job, because that will make sure the respective members are refreshed. It will make sure that the new parameters are honored in the generation. So it will do all of that for you without having to do step 1, then go to the next panel, perform step 3, then go back and run the parse job. So all of that is encapsulated in generate. And most of the time, if you're just replacing load modules and such, generate is the only thing that you need to do. And we are actually looking into making that even more comfortable and quicker to optimize that approach as well.
We had one final question, please, Anna, if you don't mind. We run a remote hub for MQ and a local one for KICS. Is it in the respective MQ and KICS PARM that we do the setup? So
first of all, I think that would then be 2 different runtime environments, right? And if you specify the TEM specific parameters, in my case, this is a sysplex wide one. So you can say something like KDS $sys1, where your remote TEMs for your KICS agencies, and KDS $sys2, where your remote TEMs parameters for the other agents are. So that's how you would tie this in from an RTE perspective. But again, the RTE name member is also a member that drives some of these things, right? So the answer is yes, you can model this.
I hope that answered your question. There's no more in the chat window. Good questions, actually. Thank you for
Yes,
your
yes, very good
input there.
questions.
Yeah. And if you do have further questions, of course, we only limited time here. You can contact us, I think, through the GSE website. I think there's an option. If not, I think you can ask Anna, and you can get hold of us that way. But definitely, please do, if you have questions, send us an email and we'll respond back. Thank you.
Okay.
Yep.
So I would suggest, if you want to do that, I don't think you can do it through the GSE website.
Oh,
So when you reload your presentation onto the website, I suggest you just add your email.
I've just entered my email in the chat, so you can get hold of me directly. I know I can see one or two of you who I've spoken to in the past, so you probably already have my email. But sure, if you do, contact me directly, and we can put a call together with Matthias, and we can discuss the options.
Okay. The information in the chat will be with the recordings, I believe, but the recordings will not be available for quite some time.
Okay, yeah, Matthias, if you don't mind,
okay.
yeah, we can put our emails in the slides. And
Yeah, hold on. Let me just find the chat because I'm sharing. Okay, hold on.
Okay. The other thing is that you are I have set you up with the power to now unmute yourself if you want to say anything specific to either Ash or Matthias.
Can you just give us a round of applause? Reactions?
And,
use the Zoom,
and yes,
whatever you like.
That's what I normally do. I lead the applause.
There you go. I think
I still like to do that by hand. Please remember to do your feedback forms. This was session 3BC. You can click on the link in your Bring Your Own Agenda, and the QR code is available there on the slides. Please remember that the length of session is appropriate. The appropriate answer is 5, not 9. So do please read the questions before giving your actual marks out of well, they're not out of 10, out of 9. And again, please show your appreciation in real terms by sticking your hand in your pocket and doing some donations to the Guide Dogs for the Blind or the RNLI. Get your raffle tickets and hopefully be rewarded for your generosity.
Yeah, thank you. And don't forget, there's a session tomorrow, and please do join us tomorrow, and I'll meet you then.
Yep. And if you're not already, your company isn't already a member of the GSE, you can actually get individual membership, but maybe it's better if you you get somebody at your company to invest in your education and become members of GSE. Okay.
Thanks for having us.
Yeah, you're welcome. So it looks like people are dropping off now, so I'll end the session for everybody. So goodbye, good night, see you tomorrow.
Yeah.
Bye.
Thank you, Anna.
Bye.
Thank you, Ash. Goodbye.
Cheers, Matthias. Well done. Thanks.